welcome to the next lecture. And now we are seeing voltammetry, and in previous chapter we have seen that is various basic terms which are used in voltammetry techniques and what is meant by excitation signal. In this topic we are going to see the instrumentation techniques that is used in voltammetry. So to start the instrumentation, we must have the knowledge of electrode system that is used in voltammetry techniques. Nowadays 3 electrode system is used in voltammetry techniques. There are 3 electrodes, namely working electrode, reference electrode and counter electrode. So working electrode is nothing but the electrode on the surface of which oxidation and reduction takes place. So normally, as we have already seen, the microelectrodes are used to achieve the polarization. So micro takes place where redox occurs, which is having very few millimeter square surface area, so it limits the current flow. Various different types of working electrodes are now available. And now considering reference electrode, so the role of reference electrode is to maintain the constant potential during the course of experiment. So normally saturated caramel electrode is a good reference electrode which is used. And another electrode is now electrode used is counter electrodes. So counter electrode, the role of counter electrode is allow the current pass through working a counter electrode. So there are a number of electrodes that can be effectively used as a counter electrode, that is inert metals such as mercury, pool of inert material, the inert metal that is platinum, and pool of mercury can be used as a counter electrode. This does not take part in the redox reaction, but it completes the circuit. Now during this experiment, the supporting electrolytes are used, normally alkali metal salts which are inert and which do not react with electrodes but having good conductivity. These are used as a supporting electrolytes. So what is the main application of this is this salt reduces the effect of migration and lower the resistance of the solution. So 3 electrode systems are nowadays are in use. Previously 2 electrode systems were in use, but there are some drawbacks of 2 electrode system, because in 2 electrode system the reference electrode has to play simultaneously 2 roles. That is, the first role was to maintain the constant potential between working and reference electrode, and another role played is to allow the current pass through the circuit. So this although this is quite success, but when the resistance of the solution is very high, there is current gets increases because of the IR drop, and in this case this distorted types of voltagram were observed. So normally this 3 electrode system is now always preferred over 2 electrode system. So this one is the first basic instrumentation, manual potentiostat, which can be used to record the linear type voltammograms. So as we see, there is a digital voltmeter and current meter, and there are 3 electrode system, that is normally working electrode, counter electrode and reference electrode. So we have already seen the roles of this. So this reference electrode, which is so this digital voltmeter, we can maintain the very high voltage here so that no current pass through this particular working electrode and reference electrode. So normally this is maintained at a very high electric resistance of 10 raised to greater than 10 raised to 11 ohm. So that's why, so no current allows to flow through this particular circuit. And now there is a working electrode and counter electrode. So there is current meter, so voltage is applied here and the current is allowed to pass through this circuit and output voltage is measured. So this one is the simple technique. So the desired excitation potential is selected by moving the contact C. Contact C is moving over the proper position of the resistors, and particular voltage output is measured. So but this can be used in linear sweep voltammogram, but nowadays more powerful operational amplifier circuits are used to record the voltammograms. So this is the basic idea of how this operational amplifier works. So here as we see, this one is the any voltage source E attached to one of the electrodes of electrochemical cells, Now this produces the current I in the cell, but this one is maintained at very high electrical resistance, so the no current flows through this particular amplifier, but it flows through this resistance R, and the output is measured here, either it is E out. The voltage at the output of operation amplifier is given E out is equal to minus IR. The minus sign arises because amplifier output voltage E out must be opposite in sign to the voltage drop across this resistance R. So if we solve this equation, we get I is equal to minus E out divided by R, and this value of current can be now easily calculated by measuring the output voltage. So this circuit is called as current to voltage converter. And now this basic operational amplifier circuit is used in instrumentation of advanced voltammogram. So this one is this instrument, this idea, this basic instrumentation of this cyclogram, so this one is for recording linear sweep, linear voltammogram, but slight modification we can use in different voltammography techniques. So now as we see, there are operational amplifier circuits. So this is A, B and C. Now this one is assembly of electrode, that is counter electrode, working electrode and reference electrode. Now current measuring circuit is operational amplifier C, and now it is connected to working electrodes. As we see, the potential is applied between working electrode and reference electrode, and current passed between working electrode and counter electrode is measured. So the operational amplifier B is also known as voltage follower, and now this one is having the role that it monitors the potential of the reference electrode without drawing any current through the cell. And now whatever the potential is generated here, it is given feedback to the operational amplifier A. And now there are simultaneously two roles of operational amplifier A. That is operational amplifier A, that is first one is to provide a current in the electrochemical cell between counter electrode and working electrode, and another role is maintain the potential difference between reference electrode and working electrodes. So whatever now the current is generated, now as it is maintained at very high potential, the current pass through this particular resistance, and E voltage output is particularly measured, and by using this voltage output the current, and by the, as we have already seen the during the how operation amplifier works, the currents can be easily recorded, and very good excitation signals normally directly we can get very good voltammograms we can get by using 3 electrode system and by using operational amplifier circuit. So this one is the basic instrumentation techniques, basic instrumentation that is used in normally voltammography. Thank you.